Today's chemistry topic is electron displacement effect. What is meant by electron displacement effect? That means when we consider the bonds C, 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 maybe in some cases double bonds and all you can see in the carbon chain. So due to the movement of electron, sometime in these compounds when you check the aniline and all, you can see that there is a lone pairs of electrons. So with the help, this all belongs to the electrons, right? So due to the movement of these electrons, so when the electron displaced from its position here, because of when chlorine is attached, due to the electron withdrawing effect or electronegativity of this chlorine results the displacement of the electrons from here to here. So it develops negative charge and positive charge. So due to that, due to some actions, in the case of double bond, due to the moment, there is a chance of electrons displacement. So altogether we are considering the electron displacements as an effects. Mainly 4 effects are there. First one is inductive effect, and second one the electromeric effect, third one resonance effect, and fourth one mesomeric effect. In this video I am trying to include inductive effect. Okay, inductive effect, it is having one more name, I effect. Before explaining the definition, we can go to one example. Let us consider the carbon chain in which in which terminal carbon atom, this is the terminal carbon atom which is joined to a chlorine atom here. Since chlorine atom is the most electronegative atom, fluorine, chlorine, bromine, all are said to be the electronegative ones. So chlorine atom is the most electronegative than this carbon. Yes, the sigma bonds of CCl. This is the sigma bond here. This is sigma bond, sigma bond, sigma bond. So the sigma bond of this CCl bond, this is sigma bond of CCl bond are displaced towards the chlorine atom. Why it happens? Because of the fact that this chlorine, it is said to be an electronegative. So it has a tendency to attract the electrons towards itself. So automatically what happens? There is electrons, the bond, sigma electrons of CCl bond, it is having the chance to be towards this chlorine. So what happens here? Develops negative charge, and from the carbon it lost its electrons, that's why it is having delta positive. So what happens here? The polarity, it is developed here. The magnitude of the positive charge, it is in the order, this is just to give C1, C2, C3, C4. The magnitude of the positive charges, it is written like this. C1 it is greater than C2, it is greater than C3, because this chlorine, it is attached to this carbon. So this sigma electrons from CCl bond, it is shifting towards chlorine mainly. Not only from here over, from all the bonds, because of Cl's electronegative nature, it is attracting, but the attraction, it is more from this carbon. That's why the positive charge, it is more for this carbon. The next one, from that also, from this sigma bond also, electrons are attracting towards this chlorine, but compared to this carbon, it is less. That's why here we written. So that's why we written as delta, delta positive. Delta, delta here means very, very small. That is the meaning. Then what about this one? Triple bond. From this sigma also, the chlorine, it is attracting towards this, and sigma electrons are trying to go there, but compared to C1 and C2, this is very less. From this sigma bond, the electrons movement towards this chlorine, it is less. And what about the C4? Again it is decreases. That's why we written as delta, 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 delta positive. Okay, so that means from this you understood that this effect will be decreases with increasing the distance from the substituent. Here this is the substituent, right? The substituent is chlorine here. This carbon, it is having more effect towards this chlorine compared to C2. Then C2 is having more effect compared to that of C3. That means when distance increases, this effect, it is decreases. Then go to that definition. This is said to be the permanent polarization of the sigma bond. Here you know that this inductive effect, it is happening in the case of sigma bonds. And due to this electronegativity of this substituent, what happens? The polarization is developed. Polarity means charge separation. Charge separation it is developed. So permanent polarization it is telling to be. Why? Because the chlorine, how much time it's there in that compound, it is experiencing this polarization. So that's why it is telling that it is a permanent polarization in a molecule by the influence of an atom which is having the electronegativity difference. Okay, so the influence of an adjacent polar bond or group, it is happening due to the electronegativity difference of the atoms. This effect totally we are calling the name is inductive effect. This inductive effect are of two types. It is plus I effect and also minus I effect. So what is meant by plus I effect? Plus I effect means an atoms or groups which push the electrons. So here when you consider CH3, this is an alkyl group. Different alkyl groups you are familiar with that. CH3, CH2. This is other alkyl group. It is said to be ethyl group. And CH3, then when this CH3, when it is connected to this carbon, you know that one more carbon it is needed. So it is said to be iso group, isopropyl. Okay, then one carbon atom. On that, when three CH3 groups, when it is attached, it is said to be third butyl. Yes, so likewise the naming, you knows it already. These alkyl groups, they having the tendency to push the electrons or donating the electrons towards the carbon chain. So when you consider like this one structure, this is the substituent when it is attached to a benzene ring. So about this alkyl groups, its role is to push the electrons towards this benzene ring. So that means not having the tendency to attract, they are giving the electrons to this benzene ring. So what happens? This one it is having the positive charge, and which one receives that electron, that is having the negative charge. So these groups which has a tendency to push the electrons towards the carbon chain, it is said to have electron release inductive effect or plus I effect. Generally we are saying that alkyl groups having the plus I effect, and the order of this plus I effect in the case of alkyl group, that is differ. That is third butyl, it is having more plus I effect compared to that of the isopropyl group. The structure and all I written there no, just before. Then it is greater than ethyl, which is greater than methyl. Okay, this is about plus I effect. Next one, minus I effect. Atoms or groups of atoms that attract or withdraw the electrons from the chain are said to have electron withdrawing effect or minus I effect. Minus I effect means electron withdrawing or electron attracting. Example just before I explained, CCl. So when it is there, so this Cl, because of its electronegativity difference, here polarity it is developed. So this Cl, it is because of its character, this is having the negative charge. You can see here the polarity difference, the substituent it acquires negative charge. That's why it is said to be the minus I effect. That means this substituent has a tendency to attract the electrons or withdraws the electrons from the carbon chain. Yes, that's effect, it is said to be minus I effect. But here in this case I told that they are supplying the electrons. So this they acquires positive charge, and those who receive they are having the negative charge. So this part, the substituent acquires the positive charge. That's why they are telling to be the plus I effect. Here you know that the substituent receives the electrons. That's why they are having the negative charge. That's why that effect we are calling the name is minus I effect. Okay, some examples are there. Not only chlorine, you know that lot of substituents it's there. A lot of them are showing this minus I effect. That means electron withdrawing nature from the carbon chain. First one NO2, that it is varies also, that order I am giving now. NO2 is having the electronegativity or electron withdrawing nature, it is more from the carbon chain. Then CN, then COOH, then fluorine, then chlorine, then bromine and iodine. So the I effect, it includes the permanent polarization development due to the electronegativity difference, and there is two types of plus I and minus I. And in the case of plus I effect, you studied that primary case, secondary case, tertiary case. So tertiary alkyl group, it is said to have the most plus I effect, greater plus I effect compared to that of the secondary and primary. Okay, then next we discussed on minus I effect. Minus I effect means electron withdrawing inductive effect. Okay.